Okay, this is by a viewer question. He was asking me about Howland Current Pumps and if I could make a video on that. Now, this is a very bizarre circuit. I don't think I've ever seen one in use, but it's interesting. You might run across one in school. People can comment below if they've actually seen this used. I think there are better ways to do this, and I'll try to cover that at the end. But here I go. Going to try to explain the Howland Current Pump. So there's a nice app note 1515 by Texas Instruments that will tell you everything you ever wanted to know about these things. So just go read that and skip the video. But I'm going to teach it a different way, so you might be interested in that. This is the circuit that you will see. All right. There's an op amp, and there's the plus input and the minus input. The minus input is just ground reference. The plus input is just a battery or voltage. I don't like their little thing here. I'm just putting a battery here. And so you put a voltage on the input, and this thing does something, and then it sets up a particular current that goes through your load. So it is a ground reference load, and it's in a strange place. Whenever you see an op amp, you expect the output to be over here, and this particular circuit, the output is here. The output is connected to the plus input of an op amp. So how can the input be an output? Well, in this circuit it is. So that's why it's probably very confusing to some people. So yeah, the output is here, and the op amp. So why have the op amp? It's very, very confusing. You'd say, okay, first principles, the input is infinite impedance, and so yeah, this thing's just not going to work. But I believe that the way they teach these things leads to the confusion, so I'm going to teach you a different way, okay? So the first thing we need to take a look at is a bridge, okay? And the Howland pump is a bridge. And so how do bridges work? Well, you have some voltage at the top, and that sets up some currents through the resistors, and those currents come around here, and if it's all balanced, then half the current goes this way and half the current goes this way, and everything is exactly the same. So if you look across the center, then the center points, the current will go this way and this way, but there'll be no current flow across the middle, okay? There'll be no voltage differences across the middle, okay? So just to make it easy, if this is 2V, then this is V and this is V if all the R's are the same. So let's just look at situations where you have R, and they're all the same. Then we have equal amount of current this way, equal amount of current that way, V here, and then if you measure the voltage across these 2 points, it's 0, because these are the same. So you have 0 here, okay? That is a bridge, all right? And let's take a look at a different bridge. So we're going to look at this bridge here. Let's go up here and we'll call this 2V again. Okay, and we have V here, we have V here. Okay, and all of our R's are going to be the same. R. Okay? And you can say, okay, now we're going to have a balanced network. Well, are we? Here's a battery in series. So if this was a 0-volt battery, then it would be balanced. But if this has some voltage on it, okay, then it's not going to be balanced. If we take a look at this resistor, what is the voltage across this resistor? Well, it's 2V minus V, so it's just V, okay? So V equals IR, okay? So the current through that resistor is just the voltage divided by the resistance, okay? Let's take a look at this resistor. What's the voltage across that resistor? Well, it's V minus V, we'll call this V little I, okay? VI, okay? That's the voltage across this, because it's this minus this is what's across here, and that is over R. And that's going to be that's going to be this current, okay? It'll be a different current. And it will be lower, right? Because this is a lower voltage, it will be a lower current. So there's not much current going this way, okay? So how could we ever make this balanced, okay? There's no way to make this balanced because we don't have enough current here. This is stealing some of the voltage, so this won't have enough current. So let's go ahead and add something so that we can have more current. Okay? We are going to add a resistor here so that we'll have some current going this way and some current going this way, okay? So the current going this way is this, okay? The current going this way we'll call little I, okay? So if we take this current and we added this current, that's going to be our big I. Our current going this way is our big I, right? So we have some going this way, we got some going this way, okay? And now we can balance it, all right? So let's take a look at this formula here. We have I, which is just V over R, okay? So we have V over R minus VI over R. Okay, that's this. You can break out the R here and the R here, and this is the same thing. Plus our little I is now equal to V over R. Okay? All right. So if we want to solve for little I, okay, little I is going to be, we're going to take this and we're going to subtract it from the to move it over here, okay? So we'll have V over R minus V over R plus VI over R, okay? And guess what? These two cancel out. So little I going this way is equal to VI, which is the battery voltage, divided by the big resistance, these guys, okay? And that's our new formula, okay? It's just little I equals this voltage divided by R. And that is a current pump. That is the Howland current pump, okay? There exists some balance such that this is true, and whatever this voltage is, divided by whatever resistance the bridge resistors are, equals the current. It's independent on the value of this resistor. Remember, I didn't even label it. This resistor has no label. It doesn't matter what that resistor is. It only matters of the other parts. And that's how it can be a current source, because the current is independent on whatever you have here. Big resistor, little resistor, doesn't matter to a certain extent. The circuit only, maybe only have plus or minus 12 volts to deal with. So anyway, the interesting also with the current source is it can be a current sink, okay? If you have a negative voltage here, then instead of the current going this way, it's going to go that way. So it can be either a plus current or it can be a minus current, all right? So I did one big hand wave, which is I said that there is a condition where this is balanced, where this is true. If this isn't balanced, it's no longer true. So we need to make sure it's balanced. And the way that you make sure it's balanced is by varying this voltage here, okay? For a given V little I, there is some voltage here that creates a balanced condition. We don't know what that is, but we know that there is one, okay? We're going to take this and this, and we're going to run them into an op amp and drive this node here. Okay, so this op amp is going to take a look at this voltage and this voltage, and it will change its output such that these two become the same. And when these two become the same, it's balanced. So this op amp's job is to monitor these two voltages and force this voltage to be in a condition where everything is balanced. So this is the feedback. It feeds back on this side, and it feeds back on this side, comes back around, and it's always looking and changing this top voltage up and down until you get a balanced system. And then this equation will be true. Okay? So if you look at my drawing and you turn it sideways, okay, and now we've got, here's this, here are these two resistors, here are these two resistors, here's the battery, and then here's this extra one. Oops, I'm sorry, you couldn't see all of that, could you? Let's see if I can do that. How can I do this? I don't have enough camera here. Let me zoom. Oh, there we go. I can zoom out. All right, let's do that again. Okay, op amp, that resistor, that resistor, that resistor, that resistor, and the battery input here is this battery, okay? And then we need to have this one, which is this. This goes to ground, this goes to ground, okay? So these two things are the same circuit. It's better to draw it this way to get an understanding of it, but this is the way you'll always see it. And then they'll bury you in math, and you'll still not know how it works because they buried you in math. Don't like the current system for education. Anyway, there you go. That is a Howland current pump. Now, there are many other things that we need to consider.